The next page begins products. And of course, it begins very simply. For example, I just want to show you how simple this next page is. If you got panic-stricken at the bottom of page 87, take heart, because number 21 on the next page, it says the square root of 7 times the square root of 3. And what do you do when you have a product of radicals? Multiply them together to get the square root of 21. Gee, is that tough? Okay. Now, it gets a little more interesting than that. Suppose you had a problem like number 27, where it says the square root of 15 times the square root of 55. Now, in this case, if you use your calculator and multiply these numbers together, you're going to end up with the square root of some big, huge number. What does that come out? 15 times 55. We got a calculator handy? 15 times 55.
825.
825. But you don't want to have to work with a big number like that. So instead of multiplying it out and getting a big number that you don't know what to do with, let's break it down. Instead of 15, what would you put?
3 and 5.
5 times 3, 3 times 5. And what about 55? 11 times 5. And you can see in that you have a pair of 5s. And that pair represents a perfect square. Okay? So if you take that 5 times 5, we could split this up now and make it the square root times the square root, where we'll take the perfect squares, 5 times 5, that would be 25, and take the leftover numbers, which is 3 times 11, so you'd end up with 5 times the square root of 33. Okay? So that's a handy way to do a product. Instead of multiplying it out and getting a big number, break it down into its prime numbers. Now number 30, it says the cube root of 98 times the cube root of 35. And I want to break those down. Now with a perfect cube root problem, what we'll want to do is look for 3 of a kind, because it'll take a perfect square, will be represented by a pair of numbers. 3 factors the same would be a perfect cube, like 3 times 3 times 3, or 7 times 7 times 7. The cube root of 7 times 7 times 7 would be 7. So anyway, let's break this down. 98 is going to be, 98 would be 49 times 2. And 49 is actually 7 times 7. So I got 7 times 7 times 2. And then 35 is actually 7 times 5. Now do you see I've got 3 sevens? 3 sevens right here. So I've got 7, 7, 7, and the cube root of 7 cubed. In other words, let me make this in 2 cube roots. But instead of putting 7, 7, 7, I think what I'd like to do is just put 7 cubed. Do you see that? There's no need to calculate 7 times 7 times 7, is there? Is there any need to calculate that? Because what are we going to do with it? Take the cube root of it, which would give you 7. So the answer is going to be 7 down here. Now what's the leftover number? 10. Okay, so that would be 10. So the answer is 7. The answer is 7 times the cube root of 10. 7 times the cube root of 10. Any questions on that? All right. Now, continuing on, we get some other products. Some of the products that we'll have to do will be like distributive property and the FOIL type problems. So I think probably on page 89 would be a good place to look at one. On page 89, you have 8 minus the square root of 3. This is number 44, sorry about that. 8 minus the square root of 3 times 6 plus the square root of 3. And what I need to do is FOIL it. Take the first times first, which would be what? 48. All right? And then the outer times outer would be, now this is tricky, get ready. 8 times the square root of 3 is going to be 8 times the radical 3. Okay? Then this is not in a radical. This is not radical 8. If it was radical 8 times radical 3, then it would be radical 24. But it's 8 times radical 3, which is just simply 8 times radical 3. And then the inner times inner would be minus 6 radical 3. And then the last times last would be negative radical 9. Okay? Now radical 9 turns out to be 3. So if you wanted to, you could just put 3. Whatever you do, don't put radical 3. That's the most common error that people make on this, is to put radical 3. It is not radical 3. Now let's simplify this. You'll have 48 for the first term, 48. This would be 8 radical 3 minus 6 radical 3, which combines together and gives you plus 2 radical 3, and then minus 3. Now what? Anything that combines? 48 minus 3. 48 minus 3 would be 45. Okay, 45 plus 2 radical 3. 45 plus 2 radical 3. Any questions on that? Okay? Now, a more complicated problem would be like number 48 on the next page. Number 48 on the next page. Fix my 64 up there. We might need those numbers again. Number 48, the problem says 6 square root of 2 minus 4 square root of 3 times 6 square root of 2 plus 4 square root of 3. All right? So we'll FOIL this. The first times first. 36 times the square root of 4. Okay? Then we'll do the outer times outer. Outer times outer would be plus 24 square root of 6. Inner times inner is a minus 24 square root of 6. Oh, that's nice, isn't it? And the last times last, so I got to get the right color. Last times last would be a negative 16 square root of 9, which is 3. If you put 3, that's fine. If you didn't put 3, we're going to put 3 on the next step, aren't we? So this would be what? 36 times 2. These 2 subtract out, don't they? They're gone. They don't always subtract out, but sometimes. And then this will be, the last part would be minus 16 times 3. So what you'll have altogether would be 72 minus 48, which is 24. Okay? 24 for the answer. Any question on that? Okay? Now, sometimes you'll have problems where you have to learn to reduce a fraction. And in particular, I'd like to do number 16 on page 92.